1.2 multiplying matrices. There are two types of multiplying matrices, and one is kind of easy and one is kind of complicated. But the first one is multiplying by a scalar. Multiplying by a scalar or multiplying by a number. Multiplying by a scalar is similar to the distributive property. And you're gonna like that. So example 1 says calculate 4 times a. So all I'm gonna do, I'm gonna squeeze in a little 4 right there. And it's like 4, 4 times a is just 4 times every single number in the matrix. And so imagine if it was distributive property times every single number in the matrix. That's not going to be too bad. 4 times -2 is -8. 4 times 5 is 20. 4 times 0 is 0. And 4 times 1 is 4. That's all it is. We just multiplied by a scalar. We multiplied by a number. Now, unfortunately, the rest of the lesson is a lot more complicated than that. So don't fall into the trap of trying to do this every time. Great, we can do this when we can do this, but once we start multiplying two matrices, it is a lot more complicated. All right, so in this gray box, I made a typo, and so I'm going to skip it. I'm going to come back to it. I think once I show you an example, it'll be more obvious what my typo is. All right, so example 2 says, if it is possible to multiply the matrices, sometimes it won't be, determine the size of each product. Okay, so we have to look at the sizes of the matrices to see if it's even possible, and that's kind of our first move. I see a 2 by 3 times a 3 by 1. Is that what you see? Now, remember, rows before rows, right here. Rows, rows, columns. Okay, rows, columns, rows, columns. Here's how it has to be. These two numbers must be equal. If they are not equal, then you can't multiply those two matrices. If they are equal, then you can multiply those two matrices. And not only that, the answer is going to be this dimension. Okay, we can see that the answer is going to be 2 by 1. So it is possible to multiply these, and not only that, we know the answer is going to be a 2 by 1. That's important. That's a really important concept. You're going to have to think about that on every single one of the problems. Okay, so we move on to the next one. I'll show you another example. This is a 2 by 3 times a 3 by 2. And again, you're looking at these two numbers. If those two numbers are equal, it works. And not only that, your answer is going to be 2 by 2. Your product is going to be 2 by 2. Okay. The third one shows a 2 by 3 times another 2 by 3. We don't really need to write RC every time. I'm just doing that to highlight my mistake, my typo I made in that gray box. We'll go back to that here in a second. But we look, and this time we see that these two numbers are not equal. If they're not equal, then this multiplication is not possible. This one is not possible. Fair enough, easy enough. Now go back and let's look at step 1 in that gray box. It says the number of rows of the first matrix must equal the number of columns of the second matrix. That's not what I did, right? The number of rows of the first must equal the number of columns of the second. I got that backwards, didn't I? It's the number of columns of the first must equal the number of rows of the second. So my typo, let's just change this to columns. The number of columns of the first matrix must equal the number of rows of the second. There we go. Now that's going to work. the resulting size equal the number of rows of the first times the number of columns of the second. Okay, now it's right. If you fix that typo right there, fix my mistake, now that works. That's the rule. But you don't want to look at the words, just look at the example. The two inner dimensions have to be the same, and the two outer dimensions is going to be the size of the answer. That's how it's going to work. How to multiply two matrices. I think a lot of times when we get steps like this, it's more confusing than actually seeing an example. But determine the size, and if it's even possible, build a blank skeleton matrix, and then we'll do the number. Then we'll multiply. Okay, and I use the phrase zip the numbers when we're multiplying. That's when I'm zipping up the numbers. All right, zip up just like a zipper. All right, so if I'm doing this example number 3, multiply the matrices if possible, the first thing you want to do is determine if it is possible. So I see a 2 by 3 times a 3 by 1. And so you look at these two numbers, the inner dimensions. Is this going to be possible? Yes, because these two numbers are equal. But not only that, we can see that the answer is going to be a 2 by 1. So we know that it's possible, but we also know that it's going to be 2 by 1. Rows before rows, that's 2 rows and 1 column. So I think this is important to build a blank skeleton matrix, all right? I think people that do this are more likely to get it right. People that are like, I don't need to do this and skip it are more likely to get it wrong, because it is kind of confusing how to get these answers. So I know my answer is 2 by 1. 2 by 1. So what I'm going to do over here is I'm going to go, all right, and what I'm going to do is just kind of make like a space, and a space. Those are not numbers or anything. That's just kind of a blank space for me to fill in numbers for a 2 by 1 matrix. Do you see how that's going? When I put numbers there, it's going to be a 2 by 1. That's going to be a 2 by 1. Okay. Now, I have to, it says step 3, number each row of the first matrix and each column of the second matrix. Normally, I don't really do that. What I do is I'll go first row, first column, okay? If you're going to multiply it, I don't really write the numbers, but the first row times the first column is going to be the first row, first column entry, all right? So that's just, the little line helps me to organize and helps me to zip up the numbers. All right, that first row times the first column. I don't really want you to circle these, but you do the first one times the first one. -5 times -2 is 10. Okay, plus. It's always plus. You take the second number times the second number. 3 times 1 is 3, plus. And then the third number times the third number, -5 times -6 is 30. If it should happen to be a negative, then fine, add a negative. But it's just, you're always going to combine those numbers. 10 plus 3 plus 30 equals 43. So I know that top number is going to equal 43. Now we do the same thing for the bottom. Okay, and again, you're probably not going to want to write a whole bunch of little lines there. If you do, it needs to be light so you can still see the numbers. You don't want to completely scribble through the number so you can't read it anymore, but you zip up the numbers. And I don't think you want the circles, because the more you write on here and scribble on here, the harder it's going to be to read. But you're taking the first number times the first number. 4 times -2 is -8. And then the second number times the second number. -5 times 1 is plus -5. If you want to write that as -5, go for it, okay? But you're adding a -5 or subtracting a 5. -2 times -6 is a positive 12, so I'm adding a 12. -8 minus 5 is -13, plus 12 is -1. That's my answer. That's my 2 by 1 product. That's my answer, okay? That's the concept. Students really struggle with it, all right? It's not the easiest thing in the world to do. So we look at the next one, and the first thing you want to do is just look at the size. See if it's even possible. You've got a 2 by 3 and a 3 by 2. Is that going to work? Yes, because these inner dimensions are equal. Not only that, we know the answer is 2 by 2. You should be able to quickly establish that yes, it works, and it's going to be 2 by 2. So draw a skeleton of a 2 by 2. All right. Some people will say, well, I don't need to do that. But I think until you get good at it, I think it's a good idea. So a 2 by 2, what's a 2 by 2 look like? You got here and here and here and here. It doesn't matter if you draw it too big. Too big is better than too small. But leave yourself room to write the numbers in those spaces, okay? Those circles, those ovals are just blank spaces for you to write numbers. Make sure you've got a 2 by 2. Otherwise, you're going to get super confused, all right? Now, for me, when I zip up the numbers here, I usually only do it once. I only write the little line once. But remember, it's always rows before co's. And notice, how many numbers did I draw a line through? 3 and 3 more, right? And that's this. That's why those two numbers have to be equal. Those two numbers have to be equal because they're going to match up. Those 3 numbers are going to match up with those 3 numbers. All right? So you do first times first, second times second, third times third. That's going to be 8 plus 8. 2 times negative 2 is negative 4. 8 plus 8 minus 4, that's 16 minus 4, that's 12. So I know my 1, 1 element is 12. My 1, 1 element is 12. So here's where your eyes kind of get crossed and you don't really know where to go, but just think about it, okay? If I multiply row 1 times column 2, that's going to be my row 1, column 2 entry. Row 1, column 2 is going to be over there. Row 1, column 2. So when you zip up those numbers, you've got 2 times negative 4. 2 times negative 4 is negative 8. And negative 2 times negative 6 is plus 12. And 2 times 6 is plus 12. Stop me if I screw something up and miss a negative sign or whatever. Okay. Sometimes when I'm that close to the screen, I miss a negative. But that looks like what? 4 plus 12 is 16. 16. Your 1, 2 entry, or your first row, second column entry, is 16. And that should make sense because we multiplied the first row times the second column. So you keep going. And once you figure it out, it's like, yeah, I got this. But you got to get there first, all right? And that's not the easiest thing in the world to do. So again, I don't really like drawing lines through all of these because it gets super confusing. But I want to do the second row times the first column, which would be the second row first column entry in my skeleton. So, I usually just point my fingers. Okay, I'll take my 2 fingers and I'll point at those numbers, and that's going to multiply and give me 4. And then I'll point at those 2 numbers, and that's going to be minus 24. And I'll point at these 2 numbers, and that's going to be minus 12. So that's negative 20 minus 12 is negative 32. And then I do the last one, second row, second column. It's going to be that last entry, second row, second column. First number is 1 and negative 4, that's negative 4. Middle number, 6 times negative 6 is negative 36. Last number, 6 times 6 is 36, so plus 36. Notice if you get a positive number, it's plus, and if you get a negative number, it's minus. That's how I do it. So the 36 cancel, I get negative 4. Negative 4, there's my answer. Now we can multiply. Now we can multiply. So we look at the next one. And your first question is it possible? We've got a 2 by 2 times a 2 by 2. Yes, that works because those are equal. And not only that, we know it's going to be a 2 by 2 result. So set up your skeleton as a 2 by 2. You don't have to do ovals. You can do rectangles if you want, or just like a line if you want, like an underline. It doesn't really matter, just as long as you understand that it's a 2 by 2 and where everything's going to go. Okay, let's do this one out of order. Okay, let's do this one out of order. We don't have to do it in the same order every time. Let's do the 2, 2 element first. If I was going to do the 2, 2 element, that means second row times second column. If I did second row times second column, second row times second column. Okay, so if we zip up the numbers, that means 3 goes with what? 3 times what? 3 times 0 is 0, and 5 times 1 is 5. I did the second row, second column, and I got the second row, second column entry was 5. Let's do the second row, first column. Second row, first column. Second row, first column. 3 times 1 is 3. 5 times 0 is 0. Second row, first column entry is going to be a 3. You don't have to go in order, and I might only ask you for one of the entries. Maybe I don't ask you to do the whole thing. Maybe I just ask for the third row and the fourth column or something like that. Okay? So now let's just do 1, 1. First row, first column. First row, first column. 2 times 1 is 2. 1 times 0 is 0. That's going to be a 2. And first row, second column. So first row, second column. 2 times 0 is 0. 1 times 1 is 1. Gives me 1. Notice that the answer is the exact same as the one we started with. Okay. That second matrix with the 1s and 0s is called the identity matrix. And that's kind of like you're multiplying by 1. All right. It's basically the matrix equivalent of multiplying by 1. And we got the same exact matrix we started with. Identity. The identity matrix is composed of 1s along the main diagonal and 0s elsewhere. If you see I2 is a 2 by 2 matrix and is going to look like this. 1s along the diagonal and 0s elsewhere. That's the identity, the 2 by 2 identity. I3 is going to be a 3 by 3. So again, it has 1s along the diagonal and 0s elsewhere. That is I3. Remember, it's the matrix equivalent of 1. Okay, sort of. I4, 1, 0, 0, 0. 0, 1, 0, 0. 0, 0, 1, 0. 0, 0, 0, 1. We've got 1s along the main diagonal and 0s everywhere else. That's I4. And so on and so on and so on and so on. If I asked you to draw I5, would you be able to do I5? It's just a 5 by 5. You got 1s along the diagonal and 0s everywhere else. That identity comes up a lot. Okay. Find A, B, and B, A. What do you notice about the products? Okay. So I can edit that out maybe. Hang on. Hello? Okay, can she wait till the lesson is finished? Or does it need to be right now? Okay, sure thing. All right. Michaela, student services when I'm done. Thank you. Okay. Example 5, find A, B, and BA. What do you notice about the products? Well, let's just set it up. When you multiply, I would highly recommend you rewrite it. If you were doing this problem on Math Excel, I would definitely want to rewrite it on a different piece of paper. I don't want you to do this in your head. There's too much going on. Very difficult to do one of these problems in your head. Okay, so when we multiply, the first thing is figure out if it's even possible. Okay, I've got a 3 by 2 times a 2 by 3. We can see that those two are equal, and the answer is going to be 3 by 3. All right, so we know it's going to work, but not only that, we know it's going to be 3 by 3. So we would set up a skeleton 3 by 3. And then it's just row times column, row times column, row times column. I'm going to have to do that 9 times. So row times column. Again, I almost always will at least do this 1 time, row times column. If you just draw that little bitty line like that, it kind of just helps your brain organize that we're going this times this. If you don't do that, a lot of the times you get cross-eyed and you get to the wrong numbers or whatever. But I'm doing the first number times the first number, and then -3 times 3. I've got that. So I know my 1, 1 entry is -8. And so I just keep going. I'm going to do the first row that I've already got a line through times the second column. And so I'll just point, 1 times 0 is 0, and -3 times 1 is -3. That means my row 1 second column entry is going to be -3. And then I keep going. I do my 1 times -1 is -1, and my -3 times 4 is -12. That's going to be -13 right there in my first row, third column. Now I move down and do the second row. Second row, 7 times 1 is 7, 2 times 3 is 6, that's 13. Second row, second column, 7 times 0 is 0, 2 times 1 is 2, that's 0 plus 2 is 2. Second row, third column, 7 times -1 is -7, 2 times 4 is 8, -7 plus 8 is 1. Third row, you do third row times each of the 3 columns. -2 times 1 is -2, 5 times 3 is 15, -2 plus 15 is 13. Third row, second column, -2 times 0, 5 times 1, get 5, and -2 times -1 is 2, 5 times 4 is 20, 22. 3 by 3. All right. So again, the question says find AB and BA. What do you notice about the products? So now let's do BA. And again, I think it's wise to rewrite the problem. So if I was going to multiply this, I'd probably write 1, 0, -1, 3, 1, 4. That is my B matrix. Now I'm going to multiply that times 1, -3, 7, 2, -2, 5. Notice you read a matrix like you read a book, left to right, top to bottom. Okay, so I always look and see if it's possible first. 2 times 3 times 3 by 2. Yes, it is possible, but not only that, it's going to be a 2 by 2. So, aha! Before I even do this multiplication, what do I notice about the two products? They're going to be what? They're going to be different dimensions. They're not going to be the same. I'm not going to get the same answer here. It's not even going to be the same size. All right, so I've got a 2 by 2. So I set up my 2 by 2 skeleton. And so that should be easier, right? Because there's less to do. There are fewer entries. There's only 4 instead of 9. But you still have to organize. We want to do first row times first column, and I call it zipping up the numbers. First one times the first one, second one times the second one, third one times the third one. Zip. 1 times 1 is 1. 0 times 7 is 0, and -1 times -2 is +2. So my first entry, 1, 1 entry is 3. Now I do first row, second column. You're always multiplying a row times a column. First row, second column. 1 times -3, 0 times 2, -1 times 5. That's -8. Now we need to do the second row. Second row, first column entry. Second row, first column, that's going to be 3 plus 7 minus 8. 10 minus 8 is 2. Second row, second column, 3 times -3 is -9. 1 times 2 is 2. 4 times 5 is 20. That's -7 plus 20 is 13. 3, -8. 2, 13. Okay, so we already said it. What do we notice? Well, we notice A times B does not equal B times A. And that's counterintuitive, because you guys have done math a long time, and it's always been like 3 times 4 is the exact same thing as 4 times 3, right? You multiply it backwards and you always get the same thing. Well, that's not so with matrices. You have to be really, really careful and understand that you can't multiply backwards and forwards and get the same thing. You're going to get different things. Suppose you could possibly get the same, but it's not a guarantee like it always has been in the past, okay, with just plain old numbers. All right, good luck.